Hey everybody, I'm Dan Jones. I'm a product manager at a company called Skytap, which we'll talk a little bit about. And I have Petr Novodvorskiy with me, who is a development lead on our tools team. So we're going to do a little tag teaming. I'm going to kick us off, and then Petr will come up, do some stuff, and then you'll get me at the end. And we will save some time for questions, so jot those down, and we'll have a mic that we'll pass around. Cool? All right. All right. So what we wanted to share with you was our journey that started back in 2014 around taking our cloud service that was made up of several I'll call them monolithic services, and how we approached breaking those up into microservices and adopting Kubernetes. And our Kubernetes adoption started in early 2015. So you kind of got to put your context around this back then and what the landscape was with containers and Kubernetes and the associated tooling. So we'll talk about where we got started, where we are now, and how we got from point A to point B. And then we'll share some parting wisdom with you. So Skytap is a public cloud. Our focus is around traditional applications. If you think about a Fortune 5,000, a fair percentage, 75, 80% of their 80% of their application portfolio are traditional apps. They were born in the data center, not born in the cloud. Well, we're the cloud for those apps. It's a fairly straightforward lift and shift of those apps out of the data center to put onto the Skytap platform. We operate in 7 regions for multi-tenant, 3 in the US, Toronto, London, Australia, and then Singapore for APAC. And then we have a few customers that want dedicated regions. Their workload requires that they can't be mixed with others. So we have 3 single tenant, and then we have 3 regions that are pre-production regions. Pretty much at any point in time, we have 20,000 plus VMs running concurrently across the globe. These are customer workloads that are running, which comprise about 59,000 vCPUs, 115-ish terabytes of RAM, and over 2 petabytes of online storage that those customers are actively using. So it's not a small footprint, it's geographically distributed. Our customers demand production out of us, so we need to be up and running.
Hey, so I'll talk a bit about what Skytap was when we started working on this. So as Dan said, we're a collection of very monolithic services running on VMs. We're provisioning our third-party dependencies with Puppet, and we would tag our source code and just deploy it with Mercurial on our hosts. So deployment process was fairly slow, and we had these big monolithic releases at the time because essentially all the VMs were maintained by 2 teams. One team would deploy source code, the other team would deploy third-party dependencies, and we all shared this gigantic Puppet configuration. And it was really painful, and QA was really afraid of all these discrepancies, and there was a lot of fear, uncertainty, and doubt. And of course, there was no ability to roll back bad deployment. After you rolled out something, for example, on test stack, you roll it out fixed on top of it instead of rolling it back and rolling out the good version. The same thing happened with production. So the whole deployment process required an orchestration between multiple teams, and releases happened essentially once a month, sometimes less often. And it was the big rollouts. So this is really simple diagram of what was there. Essentially, almost we would handle our HTTP connections, or with the 5 load balancer, everything inside of the cluster was communicating over RabbitMQ. So we didn't have direct TCP connections between services. We used MySQL, Elasticsearch to store logs, yada yada. And we would deploy source code directly on our servers. So there was no production of artifacts that we would first create and then deploy on the servers. So nowadays, we converted a big chunk of everything we have to Kubernetes. We converted most of the services that have a high release churn. That was one of our priorities to Kubernetes. We split services that were more stateful into stateful and stateless parts and migrated stateless parts into Kubernetes. And all the services that has been created since beginning of 2016 are already running Kubernetes. We prioritized services that had higher release churn. And one of the reasons for that was that developers of these services would be the most frustrated with existing development tools, and they were most accepting to make a big change. And what I would be talking in this talk mostly is how we as a tools team, we're essentially a site reliability engineer team in Skytap, had to deal with this fear of change that our developers had. So, now it's all good. Ops are not maintaining anything inside VMs anymore, inside of containers. They can focus on maintaining our fabric, essentially networking and deploying our hardware in our geographical regions. And QA is confident that if something goes wrong, they can roll it back. So our release process is much smoother, and we can release pretty much every week or like every 5 days. So this is a diagram of what we have today. Essentially, one of the things that I want to notice is that we're not running on AWS or Google Cloud Engine or any other public cloud. So there are certain challenges associated with deploying Kubernetes outside of the public clouds with which it's very integrated well. So for example, integrating a 5 load balancer with Kubernetes was one of the such challenges. So we decided, we started the project migrating Kubernetes in 2015, and there was no tectonic. I wish there was. And the only way to deploy Kubernetes at the time was using the salt scripts that Kubernetes provided. And we had our own deployment tools, so instead we had to understand how all this works and convert it to Puppet and convert to our deployment tools, which took quite a lot of time. But essentially, we made some changes. We run etcd nodes separately from masters on separate machines. That's demonstrated here. So current state is we have, in production, we have 70 Kubernetes nodes. They're in 11 clusters. Essentially, we have 10 geographic regions that we run our customers' VMs, and one management region where we orchestrate everything from. So all of them have their own Kubernetes cluster. There are 70 Kubernetes nodes running across all this stuff. That's not counting all the masters and etcd nodes. They're separately. We have around 1,000 pods running at any given time, but it's growing very, very fast, the number of pods. And we maintain staging and pre-prod environments for QA, and we maintain separate stacks. They are production-like for every developer in the company.
Yeah, really quick, I'm curious, if you look at these numbers up here, is there anybody running anything similar in size or bigger than this? No? One couple back here? Yeah, we get asked that question all the time. Like, it doesn't feel big to us because we started small, but it's grown over time. And so when we talk to people and we kind of explain this, they're like, wow, that's really big. So it's good to kind of do that barometer check of where we land out there. So when we started this kind of late 2014, early 2015, what were we aiming for? Well, our development team, our engineering team, I should say, which was comprised of dev, QA, and operations, was about 35 people. And we had just closed a round of funding, and we knew we were going to grow the team substantially. Basically, today we're more than double than that in size. The other thing was we knew we were going to have more customers come on board, and we were going to expand to more regions. So back then we were probably in about 4 regions, so we knew region growth was going to happen. We also knew the code base was going to grow and get more complex. And so in order to simplify deployments, we knew we had to reduce the size of every deployment and reduce the amount of code that comes along that hadn't changed to ultimately reduce risk and improve the reliability of the service. Microservices seem like a reasonable architectural pattern to employ at that time. As we started to break things up, just conceptually on the whiteboard, you saw the complexity grow. So when you have a few services that are talking to one another, from a monitoring standpoint, that's fairly straightforward. When you have 1,000 plus pods talking to one another, plus legacy services talking to that, the complexity in terms of monitoring and orchestrating deployments and changes across regions grows pretty rapidly. And so we had to plan for that. The other thing that we had to plan for was the changes to our release pipeline and what complexities that was going to drive in terms of pumping changes through the pipeline, through the QA and deployment pipeline. And so naturally we landed like, let's pick off the easy stuff first. Let's start there. Let's not start with the hard stuff. So where we started with the easy stuff, set out some guiding principles. We use these to help guide our decisions because every day multiple decision points cropped up. And so as a team, establishing these gave us that decision-making framework for deciding, do we go left, right, or keep going center? Change as little as possible. When we're sort of the old adage of changing the engines on the plane mid-flight, like we had customers in production, and so we knew that we had to do this incrementally, and at each stage, just minimize as much change as possible, but keep moving forward. We had a fairly complex tools pipeline for pumping changes through our delivery pipeline. We didn't want to spin up a parallel pipeline for Kubernetes and for containers. So we needed new tools and our existing tools to work hand in hand. As we looked at the problem, we recognized that for the foreseeable future, if forever, kind of the old and the new were going to have to live side by side. And so we didn't want developers to have to flip between an old set of tools, legacy set of tools, and a new set of tools. So we wanted them to work together. And then the other stake in the ground we put was all new stuff goes in the new framework. Don't increase that legacy footprint. Everything new goes in the new. So the key actions we took initially, getting key players on board. This was essential, and this happened at all levels in the organization. So it started with our CTO and getting his buy-in and commitment, and then just working our way down the management chain, all the way down to some key individual contributors on the team. The people that have the loudest voice, the people that are most opinionated. You want to try to get them on board from day one. Otherwise, they're going to put up those roadblocks, those stop signs, every chance they get, and it's just going to slow you down. And then the last thing, I've mentioned this, is being in that state of being able to run our old stuff and our new stuff side by side. Old stuff is going to continue to evolve. New stuff is going to continue to evolve. There's no point in time where you can just kind of shut one off and turn the other on. So making sure old and new can talk to one another and coexist, super critical. So let's talk, everybody likes to talk about the technology, but let's talk about the organization. Before we started on this, we had a development team, a QA team, and an operations team. And we recognized that if we were going to commit to going down the path of refactoring our services, of adopting Kubernetes, that we needed a team dedicated to driving this change. It wasn't a part-time job. It wasn't another hat that somebody wears. I'm a developer on these services, from 8 to noon, and then from 1 to 5, I'll be on the tools team. We needed a dedicated team to look at what are the options for technology out there and how are they going to integrate into our current or existing tool set. We pulled some from internal and kind of moved them from a development team onto the tools team, and then we hired some additional folks onto the team. But that initial set of individuals, I think it was 4 people. The criteria that they had to meet, they had to be deep technically. So this wasn't take them and lock them in a closet and say, figure out Kubernetes. They had to understand the existing system. They had to understand our release management and deployment systems. They had to understand our CI and CD tools. And they had to go out and teach the other developers how to migrate their services onto the new platform. So that's a pretty robust skill set to have, especially the ability to teach part. Sitting side by side, somebody on a tools team and somebody on a development team, and educating them on that process of how to refactor their service, how to plug into the pipeline in the appropriate way. Those are very in-depth conversations. And if the individual from the tools team doesn't know their stuff, the developer is just going to call BS all day long and put up those roadblocks. So a little bit about the education, because this is changing the way an organization thinks. Having the individuals on the tools team that understand how to teach, very important. We created a buddy system. So the tools team did the port of some initial services just to prove out and test out the new tooling and work out some initial bugs, get that flowing. And then they would go off to development team by development team and form like a buddy system. So that development team knew who their tools team buddy is, who to go for questions, and then they would work hand in hand for the first couple of services to migrate over, and they would do it together. Along the way, we kept documentation up to date. I know, the D word, nobody likes documentation, but it was absolutely critical. You have an organization of 60 people trying to understand what this new thing does. You can't answer those questions every single day. We used Confluence. You can use whatever tool you want. The thing we liked about Confluence was it created a community that was able to come and edit that documentation and keep it up to date. So if a developer found something that was wrong, they could correct it, and then the documentation stayed up to date. For our support channels, we use Slack very heavily. Again, you can use whatever tool you want, but every developer, every QA person, every ops person knew the Slack channel for the tools team and could ask questions there. And then again, it was the community kind of helping one another out. So nobody felt like they were left out in the cold or didn't know who to go to ask a particular question. Maybe that sounds funny in an org of 30 to 70 people, but it can happen. We hired so many people so rapidly that not everybody knew everybody else, but they knew the Slack channel to go to, or they could find the Confluence page to go to. And then the last thing to kind of help the more seasoned developers, not necessarily for the new folks, but reusing existing tools, so they didn't have to learn a whole new set of tools to use. By plugging in new tools with the existing tools and kind of shielding as much of the new stuff from them as possible, their comfort level was fairly high. And they would push out their first change, and a container would get built and deployed out to Kubernetes, and they were like, that was fantastic, that's so cool. Once you get that reaction, you've won them over.
So when we started all migration to Kubernetes, was really 2015, was really in early days of Kubernetes. So there was a lot of doubt inside the company itself. So pretty much we had to be very confident in what we're delivering inside the company so that developers don't push back, and they were trying to push back. So because developers don't like their deployment tools to change. They like to do the same thing they were doing. So essentially, what we had to educate our developers about. We definitely gave much more power to our developers. They were able to manage what dependencies they have. Before they wanted to update the version of Node.js or Python, they had to go communicate with all kinds of teams around the company, and now they just change the Docker file. But there are a lot of things that we found out developers don't really know about. For example, how to manage dependencies. What is immutable artifacts? Why is it important to pin all the versions of the products you depend on? All this stuff, they require education. There are certain things they had to add to their services. We spend a lot of time arguing with our developers that health checks and readiness checks from Kubernetes are really important. And they're like, well, we worked with this stuff for the longest time, it's fine. And we had to spend, there was a long time we spent educating developers that it's really needed. And every time we would ask something new from them, of course, they will push back. So every time we'll have to say, well, these are advantages that you get from this. Yes, you'll spend some time doing this, but this is a amount of advantages. So there was a lot of selling process that was going on during education phase. The other part was estimating resource usage. During migration to Kubernetes, we actually lowered our general compute consumption of our software significantly, because before we would just eyeball, well, this service needs some amount of CPU and RAM, just create a VM and go. And for all servers that they were migrating to Kubernetes, we started requiring them to specify exact amount of CPU and RAM they require, so that we can pack services better. And teaching them on how to estimate this took quite a lot of time. So, as I said, our developers were very happy with changing all their development tools to release tools. The other thing is that we already have a release management process, and our tools, they're fairly archaic, I would say. Our main deployment tool called Skytap is built on top of Capistrano, like on the version from 2008. We're pulling fixes from that time, but essentially it's heavily modified, half rewritten version of Capistrano. It's not super nice, but the key thing about it is that it has a lot of knowledge about release process already built in. Because we're using it for so long time, all the quirks in our release management process are baked into the code that we have. So while there are all this amazing new CI/CD system out there in the market that we could use, we decided to go with what we have and instead try to adopt Kubernetes paradigms to the tools that we use already. And that allows us to change less things and educate people less. The other thing is we try to choose the services that we had to modify the least to get working in Kubernetes. And there is a methodology that we use to understand which services we would go first with and which will go next. So essentially, we're looking at three things. One is we're looking at the services that have high release churn, that have new features all the time, that get deployed all the time. They obviously benefit from deployment on a platform like Kubernetes more because, all things go more smoothly through a QA process, as I said before. The second thing is a communication model. Especially in 2015, there were like multiple competing networking models in Kubernetes. There's still a bunch of them, and it felt like this whole question is not set. And we were lucky in a way that most of our services are using RabbitMQ, so they don't listen on particular TCP ports. They just reach out to RabbitMQ server and pull messages. So in between choosing the services that listen to a TCP socket and services that just pass messages, we chose the ones that pass messages because it doesn't require any special networking configuration. And of course, in choosing between stateful and stateless services, we chose stateless, or if we had stateful services, we broke them down apart. Well, they were our proprietary services into stateful and stateless parts, and deploy stateless part into Kubernetes. Now, I don't say that you cannot deploy stateful services in Kubernetes. I think, especially in end of 2016 and 2017, Kubernetes made a huge progress with stateful sats too. So we're looking at moving MySQL Galera cluster to Kubernetes. But it's still much harder to do that than just spinning up some stateless services. So that's was guiding our choice. One other thing I want to admit is that we had certain problems, networking-wise. We had certain problems because we're running in the vSphere and our hardware in our data centers. And there are certain problems associated with it. When you run Kubernetes in Amazon or Google Cloud, you'll immediately get support for Elastic Load Balancer or Google Load Balancer. You integrate with Google Router, your networking integrates with Google Router on Google Cloud Engine. In vSphere, the support is much more basic, and considering we use F5 for most load balancing, we had to put some work to make it work. And obviously, if we could just use the services that don't listen to TCP sockets, that was much better. So now a bit about our continuous integration and continuous delivery platform in Kubernetes. So as I said, we have old archaic tool. So we spend a lot of time trying to think how we get to adopt our software in Kubernetes, and at the same time, our developers would think that they're just deploying the servers the same way they did before. So for example, the way how it was before, a developer would do, Skytap upgrade their service, and they would specify the tag in the Mercurial repository. It would get deployed on the system. What would now happen is our deployment tool will go, user will still think that it's like old times. They would specify the tag. They would tag the Mercurial repository, specify the tag when they deploy it, and our deployment tool will go to Mercurial server, resolve the change set, and then all our Docker images are tagged with this change set. So then our tool will go to Docker registry and see if there is an image with that change set. And if it's not there, it will go into the Jenkins server and ask for this image to be built. While the technology is fairly complicated, it gives full illusion for a service owner that they're deploying from the source the same way they did it before. And it works, and we're really happy that we didn't have to teach our users to do things completely differently. It took quite a while for us to complete this project. If I would think how much time was spent overall, like migrating to Kubernetes, like to our first service, we spend around 40% of our resources migrating our deployment tools to use Kubernetes. So if you're planning something like that and you haven't done it, it's a big effort, but I feel it was totally worth it. So one of the things that we developed, the other thing that we developed for migrating to Kubernetes was this tool called Jenga, that we internally call Jenga. It's a trademark, so. So the migrating to Kubernetes is like radical change. And what I've found during my career is that deployment tools are things that are tested the least in every organization. People write unit tests for their code. People write system tests for their code from when they think about, well, user is going to be interacting with the system. But people rarely write unit tests for their deployment tools. Or system tests, for that matter. When we were going to make this gigantic change in the way how we deploy things, in the way how our system is organized, we knew that if we start failing in the middle, again, we could get a pushback from our developers, like, your tool doesn't work, we should abandon the project. So we needed to be like really sure that every step we're implementing is tested and we're confident in it. So we developed this tool that will spin up the whole stack that we have that is equivalent to our production stack inside our cloud on demand. It's our biggest copy of production stack that emulates 3 geographical regions. Is fairly big. It's not really usable by our developers. It takes around 400 gigabytes of RAM and 250 CPUs and something like 10 terabytes of storage. But that's something that we build every night. We bring it up, we run system tests, and we make sure that things still start and stop and upgrade as we expect them to be. So every time we would migrate certain part of Kubernetes or make change in how we deploy Kubernetes, this stack would build, and we would know that it still works. Everything still works. We'll get green light. I think that was pretty instrumental to success of migrating to Kubernetes. The other advantage of using this kind of stacks is that when QA would be testing migrations, certain parts of things to Kubernetes, before they just had a test stack, right? And they would start something on Kubernetes, destroy old VMs, and if something failed, they're in a bad state. They cannot roll back after that with old VMs. It's not like in Kubernetes deployments where you can, oh, it didn't work, I'll just roll it back. What Jenga allowed them is throw out essentially the stacks that failed and start from the known state and try upgrade again and see if it works. And now on the daily, nightly basis, we test that everything works every day. Done.
Go for it. All right, so fatal mistakes to avoid. I'm not claiming we made these, but okay, maybe we did. Underestimating what you have. You know, if you look up at the sun from our vantage point, it just looks like a little ball in the sky. As you zoom closer and closer to it, you see all the detail and all the gory stuff that's going on in the sun. You need to think about your services, your application, your deployment pipeline, your tooling exactly the same way. Don't oversimplify it. If you're going to start down this path, zoom in, understand all the components, understand the interdependencies, understand the years of assumptions that have been made in the code and what it means to break that apart, and understand how your developers use their tools. Petr talked about not considering code, state, and data, and making the decisions for how you approach your services kind of in that way. Compute is always easier to containerize than networking and storage. Transient technology choices. I think we lucked out here. We didn't really do too much in adopting a new technology for a period of time and then throwing it out and replacing it with something else. One sort of sidebar story on this that I like is we had a customer forum a little while back, and we had one of our customers talking about their container usage, and they had adopted Mesos for their orchestration. And somebody asked them, like, well, how's that working out for you? And he was kind of like, well, it wasn't the best choice. And I'm not making a judgment about Mesos, by the way. It wasn't really the best choice. And so it was like, well, why did you choose Mesos then? And the answer was, well, a couple of our developers went to the Mesos conference, got a bunch of free t-shirts, and came back and were all excited about Mesos. So that's the direction we went. Avoid that stuff. There's lots of great technology out there. People get really excited about it. Look at what's going to work inside your ecosystem and make those choices. And then lastly, Petr's leadership here, I think, was key in setting the expectation throughout the entire organization that we are going to do a crawl, walk, run. We're going to start small. We're going to get some success under us. We're going to work out the bugs, and then we're going to get better and better and better and faster and faster. And I mean, this has been a 2-year project to where we're at now. I think if we had tried to start running really fast from the get-go, we would have failed. We would have fell on our face, and it would have been a completely big reset, and we wouldn't be where we're at today. So start slow, sell that to your management, under promise, over deliver. All right, so our parting wisdom. Customer first attitude goes a long way. This was our tools team understanding who their internal customers were. It was the developers, it was QA, and it was operations. And looking at anything that they could do to serve those constituents better created a really good relationship, a trusting relationship, and people were willing to kind of give a little bit and contribute a little bit more and not put the full burden on top of the tools team. We've talked about starting with compute. I won't belabor that one. We've talked about considering your existing tool chain. If you can't get elements of your tool chain to work with a Kubernetes pipeline, look at how you supplement, but supplement in a seamless way so that people outside that flow can't see the seams in it, that they just do their commit and the right stuff happens on the back end. Petr talked about this on 2 slides ago, which was the ability to reset environments. So we can take, within Skytap, we have a concept of an environment, which encapsulates all your compute, network, and storage. And then you can save that off as a template. So on a nightly basis, we rebuild different fidelities of our stack, save those off as templates. They're all tagged accordingly. So developers and testers can just kind of grab these off the shelf, spin up their own environment. They're isolated from everybody else. They can drop their own code in there, test it out. It's all isolated. If it goes wrong, they just delete it and start over from scratch. And the fidelities we have is something from like a 4 VM footprint to we can run a multi-region Skytap inside Skytap. So he gave you the stats. It's like 200 VMs, multi-terabytes of RAM and storage. And then it's much easier for container services to talk to other services than vice versa. The fact that we had already had message queue architecture in place in a number of areas really saved us. Don't force old talking to new. Look for ways to insulate. So if you don't use MQ today, introduce an MQ into that pipeline. It'll make your life a lot easier as services are flying around different nodes, different Kubernetes nodes, et cetera. They'll know where to communicate to, and you don't have to try to keep a registry or whatever up to date and instrument the old service to where to look for where that new service might be. So I think we have a couple of minutes for questions, yeah? Cool. Yeah, we have a mic. Sorry, I said you.
Thank you for the awesome talk. This was very informational, and it's glad to know that others are facing the same issues that we are facing. When you
Misery loves company, yeah.
Yes. So I have 2 questions. One of them is about the namespaces. In one of the slides, it said that you had 11 clusters, but 185 namespaces.
Yep.
So could you talk a little bit about how your namespaces are organized? That's one question. The second one is about the resource utilization estimation.
Yeah.
Did you use any tooling for that as well?
Mm-hmm. First, about namespaces. So essentially, we have different components in Jira, which kind of regulate. They're smaller than a team and company, but a bit bigger than single developer. And they're associated with namespaces in Kubernetes. And it's essentially a grouping of people who have access to modify the objects, deployments, or controllers inside this namespace. It's a area of authorization for people. So considering resource utilization, we just start looking at existing utilization on the cluster on the virtual machines. So we look at the load on the systems that are there. So from the CPU load, 1 CPU load on the 1 minute CPU load on the virtual machine, we can estimate the millicores that the software will use. The same thing can be said for RAM. Then we look at the maximum and we try to set the limit usually 20% above the maximum usage over last year. And we look at the 99 percentile usage, and that's where our requests go. So Kubernetes has requests and limits, and that's how we say limit is 20% above max, and request is 99 percentile. And then, of course, we we pipe all our metrics into InfluxDB, not Prometheus, just because we started in 2015. That's when Kubernetes, and we like InfluxDB a lot actually, and we use capacitor scripts that track the utilization of inside the containers and send alerts to, well, actually logs bugs to our Jira when the service is underutilized, above the request usage for a long period of time. So developers update their resource utilization in the declaration of their deployment.
So good stuff. What about your strategy for the long tail of all the crappy services that are paying to move to Kubernetes? Do you plan to move everything one day to Kubernetes, or do you embrace the fact that you're going to still have those services that are going to live out of Kubernetes forever?
So one of the things as a lead of tools team I wanted to achieve is to make sure that it's not my job to convert services to Kubernetes. I essentially say these are advantages of Kubernetes that Kubernetes gives. If you, as a developer in the team, want that churn, that smooth QA pipeline, you invest your time into that, your development time, and do that. So we try to help the teams that have the highest churn services, and we did that. But for all other teams, if they will want to do that, they'll do that. But if there won't be any initiative on their side, we won't do anything about it. Yes, but because we have our deployment tools that can do both, we don't really care. So it's okay. We support both models, and I think for some services we'll have to support it forever anyway. And so yeah.
Yeah. So for those automated periodic builds of your entire stack, what kind of stuff were you doing to actually test and verify that the stack was good and the application?
So we have first we have system tests that are written by our QA team that usually used to run against test stack. And now we just run them every time we build a full stack. And we have this thing called audit tester that we run even in production all the time that tries to exercise different call paths to our stack all the time. So we do several runs of this on our new stacks too.
Yeah, and all that's all API automated testing. We don't have any automated UI testing. So that's all manual.
Yeah. Cool.
Thanks for the talk.
Great.
I'm wondering what did you let fall by the wayside for version 1 of this whole thing?
Sorry, I didn't understand.
What did you punt on for version 1?
Oh, for version 1, well, a lot of things. So, so first we didn't have services that we were building clusters from scratch. So we didn't have kubedns running inside because we just don't need it, because we didn't need any service location because everything went to the Mercurial queues. We at first didn't even run any networking integration inside Kubernetes cluster because every node nets the workload behind what runs on the node. So we didn't have anything like Flannel or Calico running on the nodes. We just didn't need that. So it was pretty basically just we use Kubernetes to start one controller that will start multiple services. And to be perfectly honest, the first service we deployed in Kubernetes was some service that we're going to depreciate pretty soon. And it was just still running in production, but no one called into it. So we thought, well, it'll be a good thing to test upon. So we just moved it to Kubernetes and saw that it still works. And it passed the formal QA process, but customers are not in danger.
Thank you so much. I only have 5 nodes, no comparison. I'm from Stanford. I missed the beginning of your talk. Are you saying, are you running Kubernetes on, not on any of the cloud vendors?
Yeah.
So are you running on CoreOS?
No, we started in 2000. We started on Ubuntu. We're planning on moving to CoreOS, not really to Tectonic right now. So.
Okay. And the second question is that since you start very early on, I know role-based authentication, RBAC is pretty new.
Yeah.
And how do you do your authentication?
So we essentially have our, like in our tool, like earlier on, we just, we have our own custom authentication. You can run tool from a specific host, and then it looks in what namespace the service belongs to, and authenticates based on that. So we don't use Kubernetes native authentication yet, but with 1.7 and role-based authentication coming out, we started our work in migrating to that. But we're trying to look ahead at the time. That's why we started using namespaces early on.
So your developers and your team actually, do they share same kubeconfig, or do you have generate different kubeconfig?
So we have our own shell wrapper around kubectl, and and depending, and we have our own deployment tool, essentially that runs kubeconfig. People don't run run kubectl. Generally, people don't run kubectl directly. They use our old tool to deploy software on Kubernetes, because we didn't want to teach every person in the company about kubectl.
Okay, great talk. Thank you. And I'm a bit curious about the integration with the F5.
About integration with F5. So we have a tool that essentially looks at the service. It's fairly simple. It just took us a while because we never programmatically accessed the F5 before. I think it's open sourced. I can look after the talk and give it to you. But essentially, it looks at a Kubernetes service, lists the endpoints that the service belongs to, and populates the specified pool inside the F5. Pretty easy, but yeah, it's written in Python. Huh? Yes, right.
Cool.
Cool.
Thank you.
Thank you.